In this set of videos, I'm going to ask the question, can we make cars much better? And I'm going to use this as an example of how you can do ninja physics analysis of a real world problem, a real complicated problem. The inspiration of this came from a famous quote by Peter Thiel, a venture capitalist in America. "We wanted flying cars, we got 140 characters." What he's saying is that back in the 60s and 70s, when people looked to the future, they imagined flying cars, hoverboards, interstellar travel, holidays on Mars, and instead we got Twitter and petsonline.com. What went wrong? Well, if we could get flying cars, it would be absolutely amazing, or even improving our existing cars. Traffic jams, as you can see in this video, are a major problem for our cities. Just look at all those cars crawling around. The technology for cars has not advanced very fast. Here's the history of fuel economy in the United States. And what you can see is that between 1975 and 2010, or today, the miles per gallon, the fuel efficiency of the cars, has roughly doubled. It improved quite a lot between 1975 and the early 80s, then it didn't do very much and has been climbing again recently. So cars today are perhaps twice as good in terms of getting people at a given distance than cars 40 years ago. But compare that to microprocessors. Here's the improvement in microprocessors over the same time, and they are roughly a million or several million times more powerful. So your technology's advanced both for cars and for microprocessors, but cars twice as powerful over 40 years, microprocessors over a million times more powerful. What's going on here? Is it just that car engineers are not as bright as microprocessor engineers? Is Ford very badly managed compared to Intel? Or is there something else going on? Is there some good physical reason why cars are improving so slowly compared to microprocessors? And that's what we're going to try and investigate. Why are cars only advancing relatively slowly? And if we can understand what the fundamental reason for that is, maybe that'll give us some clues as to how we can solve it. Or it might tell us that it's actually unsolvable and we should move on to something else that we can deal with. So how do we go about analysing this? Well, we're going to use our three fundamental ninja principles. Go to first principles. That means don't just accept things the way they are, probe. Cars use a certain amount of petrol per kilometre. Why? Where's the fuel going? What's causing it? Why is it limited? Is there some way around it? So we're going to demonstrate that. Pick a simplified model. Modern cars are incredibly complicated things. If we try and model every gear wheel and every sensor and filter, we'll soon get buried, and 10 years later we might come out for air. So we're going to have to simplify things, and we're going to have to focus on what matters most. Odds are improvements in technology of, say, brake lights are not going to make that much difference, maybe a 1/10% or something, but they're not going to transform cars. We're looking for things that could transform the efficiency of cars.